to go ahead and introduce our two speakers. First, we've got Paul Vixie, and a little bit of background on Paul. Paul is a member of the Internet Hall of Fame for his contributions to the DNS protocol and various open source software principles and methodology. He created what's regarded as the first commercial anti-spam service, founder of Farsight Security, which was eventually acquired by Domain Tools, one of the 5 companies he started. And he's currently the Deputy CISO and VP and Distinguished Engineer at AWS. Paul is speaking here with Eric Johnson, who I've been working with for many, many years, longtime friend, longtime SANS instructor and author, the lead author of our Sec 540 Cloud Security DevSecOps Automation class, co-author on 549, our Cloud Security Architecture class, and on 510, our class all about security controls and mitigations. And Eric has been, I know firsthand, working in building secure by design systems for many years, which is exactly what this session is about. So I'm going to go ahead and turn it over to Paul and Eric.
Excellent. Thank you, Frank. Welcome to the discussion on building security from the ground up with Secure by Design. Frank did some amazing introductions, so I'll pass it over to you, Paul. Is there anything else you wanted to add to your background before we jump in here?
I think it's important to, full disclosure, back when there was just one cert, it was at CMU, and we had cert advisories rather than the whole CVE architecture and CNA and everything that we have now. There was a contest of sorts, and I was the winner. If you knew where each bug came from, who had contributed what to SendMail or the FTP server or whatever, then it turned out I was the author responsible for the most cert advisories in the 80s and pretty much through the 90s. So I learned everything that I know the hard way. Happy to share what I have learned with this audience.
Excellent. I'm sure there's lots of good lessons learned from a Secure by Design perspective in some of that background. As we take a look at the opening slide here, it kind of leads right into that. What is Secure by Design? And I know Bertram and you and myself, we all had a kind of a good run through this white paper that we put together, trying to explain some of the differences between, what is Secure by Design versus Secure by Default and how do they work together. My mind kind of shifts back to the early days of kind of home routers, where they would drop those off for you and, in a box in the store, and you'd plug it in and right out of the gate, you've got this admin website with a default username and password. That is not really something they were telling you about that you needed to change. It's kind of just the way that it worked. And of course, most users would unpack that thing, set it up, and leave it in that default state up until it was pwned at some point down the road. As you fast forward to today, we almost relive the same thing in IT over and over again, as you've got like a Kubernetes admin dashboard or Salt server kind of administration panels for infrastructure as code. And a lot of times we spin these new modern systems up in these insecure states out of the box, and you still have to go in and do something to actually address that. So Secure by Design, to me, when I think back to that evolution, is really kind of all the building blocks along the way of getting it to the point where this product is boxed up and ready for a customer to use, and ensuring that it is going to be operating in a secure state for them without them having to go through and read the fine print or read a lot of the documentation to understand those things, where Secure by Default is a component of that Secure by Design process that ensures that it's configured correctly. And you've got to kind of go through work to undo some of those settings and some of those Secure by Design aspects that we've maybe covered throughout the way. So that's kind of where my head goes. I'm interested in your thoughts on Secure by Design and Secure by Default and kind of how those work together.
Thanks. And I agree. And I guess the takeaway is that these are different things. Secure by Design and Secure by Default are often used interchangeably, which is wrong, or they are conjoined, where you're saying that you have both or you're doing both or whatever. That doesn't really make sense. To be secure by design would include being secure by default, because your defaults are going to be part of your design. But there's a lot of other things that go into the design. For example, What features do you lose when you turn on certain security related knobs? Or what are the defaults? How are the users, how does the documentation look? If somebody doesn't want to be an expert on this, what can we actually tell them enough in a reference card that came with the product and they just glance at it? Or is it going to be a danger to that user and to the rest, maybe the rest of the internet, because there is no way to make that consumer risk aware and get them to make an informed choice? And, if security is a cone of uncertainty, where you're trying to narrow it as much as possible, but you'll never have a laser beam there. It's always going to be possible that somebody will come up with something you didn't think of, or maybe it gets under the skin of what you're using. You think about Rowhammer and the way that it is possible to see adjacent memory cells because of the physics of the chip itself. Most designers were not thinking, gee, well, that's a risk I should make sure I'm not subject to. No, there's always going to be something. But the most secure system is one that is powered off, still in box, taped shut in a closet with the lights off. And in case it has a battery, you may want to put a Faraday cage around it as well. So we're not going to truly maximize security. Whatever we wish to present to the world, to our customers, is going to have a cone of uncertainty. It's going to have some security risk. And what we have to do as designers and as builders is to make sure that there's nothing that we knew about that the customer doesn't know about, and make sure that we are responsible stewards of the customer's trust. In other words, that we are appropriately trained for what we are doing. And, I was a high school dropout, so I'm not saying training requires college. I'm just suggesting that you should not take somebody who's fresh out of school and say, yeah, we really just need a front end for this thing. And, once we have it, it's going to become a SaaS offering, and nobody else will have looked at it. And all of a sudden it'll turn out you've got, I don't know, replay attacks and other things that would be commonly known by a more experienced dev. So in other words, we are the source of most of these problems, right? Humans build these systems, humans make errors. That's one of the delightful things about us. And we've got to account for that also in the design. And, we're fortunate that CISA and NIST have both taken a very big interest in this topic, and they are getting the word out on some things that really only graybeards knew up to a few years ago. So the Secure by Design pledge, for example, once it gets through, once everybody has really done everything in that pledge, and it becomes that's the new normal for tech developers, I think the rate of vulnerability discovery is going to go down, by magnitudes. And that's not something industry could have done without government helping to sort of shine a spotlight on it. So I'm really pleased by that.
Yeah, and I think that takes us right into the next topic of discussion, which is adoption. And yeah, obviously we mentioned CISA giving us the Secure by Design pledge that we can all go sign up for and work towards some of the goals inside of that. There's also some great kind of NIST standards, SP 800 218 for the secure software development framework with SSDF. On the AppSec side, you kind of mentioned the developers designing the front end and maybe not quite understanding what a secure product might actually look like. And you've got folks at OWASP doing a great job giving us like the application security verification standards and the ASVS. In these sorts of frameworks, I think are the perfect resource to maybe start with for looking at what is a secure design maybe going to look like to start with, and what is that end goal maybe going to be as we start going down the path of trying to build these things more securely. Some of this came up in the earlier session today with cloud misconfigurations, and one of the comments I saw in Slack was, are we ever just going to stop blaming the customer for making mistakes and using our product maybe in a way that we didn't intend for it to actually be used, and instead try to help them out, as you mentioned, not having to read that card step by step by step. and maybe taking the feedback from the customer and using that in incremental design improvements or to build out guardrails and maybe taking responsibility for our products and empowering our teams to actually build these better design systems out for the customers to use. So have you seen any other really interesting adoption strategies or best practices or things like that that you would recommend for folks? Is, where do I start? What do I do if we have no secure by design strategy internally?
Well, if that's your position, if that's the position of anyone within the sound of my voice, you should be prepared to raise the alarm, but you don't want to seem like an alarmist. So you're going to have to do a lot of homework so that what you say absolutely holds true, which is these are the risks and I can prove it. These are some mitigations that will reduce those risks and I can prove that. These are the investments that we're going to have to make as a company. And some of those are hard choices. It may be at some point there's a feature we'd like to add to the next generation of our product that we can't add because we don't know how to secure it. We don't know how to keep it from, accidentally but easily being used to injure the customer in some way. And so we're just not going to add that until we figure out the security paradigm for it. That's a tough choice. And trying to explain to your chief executive officer that that's a choice that you recommend he make or she make, boy, that's tough, but that's the job. Now, if we set the Wayback Machine for the early 90s, the IETF, Internet Engineering Task Force, which is where the RFC document series comes from, it's just volunteers, right? You don't get a membership card there. You don't sign a membership, a paperwork or anything like that. You just participate. But, we started to realize that the internet was going to be the thing and that the OSI protocol suite, like TP4 and X25 and X400 and so forth, was not going to be the way that humanity built a global nervous system for itself. And, a lot of us got a little concerned. This stuff may not be hardened enough. It's, it's kind of designed by academics and it's safe in that environment. But if everybody's going to use it, we need to behave differently. And so the IETF created a new area director for security. So there was one for the network and one for the transport and one for this and that. But the first area director got up at a plenary session after he had been in that job for a year and he addressed us. And I'll never forget what he said, which is, you're writing these RFC documents and you're editing them and you're drafting them and you're revising them and discussing them and you're doing a great job. But then at the very last minute, you're bringing them to the security area to get us to bless it somehow. And let me assure you that security is not like some magic pixie dust that we can sprinkle over your RFC when it's on the loading dock on the way to the printing press. Doesn't work like that. Security has to be thought about from the earliest moments. And he was oh so right. And that is still true. I think it will always be true. And, that is an example of kind of a corporate mind bender where the corporate person really has to change their outlook and say, would I rather invest up front or pay a lot more in the moment later on, with interest and penalties? And, these are the realities of the situation. So, on this slide, we're mentioning the NIST framework. There are development teams who don't even have a defined software development lifecycle. They're just doing what they always did. They don't have a name for it. Or they're, doing something that has evolved, but they don't have a name for that. They haven't documented it. They don't know exactly what assurance they're getting from it. So even if you don't adopt the NIST secure software development framework, it's vital that we all have some software development lifecycle. And, in that, if you've been working any time in the last 40 years in this industry, you're going to know that you need some automation, a lot of automation. You've got to have sort of background processes that are building your software just to see if it will build. And then if it does build, it's going to run all kinds of system and regression tests on it to see if any of those that used to pass now fail. And so you're all of a sudden you're going to be getting tickets opened by these background robots that are trying to make sure that you are doing what you said you would do and that the software actually works and so on. If you don't have that, then the amount of complexity that you could put in the hands of your customer will be dramatically less. So basically, you need to pay attention and you need to have formal rules written down and the ability to audit yourself to find out if you're following them. And then within that, there are details.
Yeah, I think automation and testing it's something that's always going to come up when you talk about the SDLC. And I think a lot of the folks that I've worked with don't necessarily understand how that can help secure by design by establishing, going from functional testing off to like security focused or audit style testing or policy as code and some of the new things like that are being adopted by some of the more modern teams to help enforce these design strategies and detect things that are maybe veering from the design or maybe something that's been disabled or misconfigured in whether it's the application or the infrastructure code or some other aspect of the system. So I think those are fundamental, probably prerequisites that kind of have to be there in order to do this and do this at scale. If you try to reuse this design across a bunch of different systems, do you have anything that you've seen there that helps kind of establish that mindset across the organization that helps adoption?
So we are, in my day job, AWS, we are incredibly fortunate that our founder was a professional software developer earlier in his career. Now, that doesn't mean that we're still running code that he wrote, but it does mean that he just established very early on that security was job zero. And so narrowing that cone of uncertainty to the point where it could not be narrowed further unless you just didn't ship anything has always been the sort of the thing that we can most easily do, right? All of the roads that are paved inside of my company are paved that way. And if you want to do something that isn't that, it's not impossible, but you'll find no paved road to get there. So again, we are fortunate in that we never had a time that we didn't have this set of security priorities. For other companies who did not have our founder, it has been effectively adopted over and over again. And all you have to do is look at sort of what the leaders in the field are doing and see which parts of that you could adopt. And you want to make sure that when you adopt it, you know what you got for your investment so that you know whether that was a good idea and whether it should inform others. And, one example, something that I have told any number of our partners and customers about is the sort of security. Oh God, I don't even know. I forgot the formal name. We have a group of people who are in various service teams. They develop things. They're in there. If you think about some product that we make, it's got a dev team associated with it, and members of that team are able to seek extra training in order to become a security champion. That's the name of it. It's the Security Champions Program. And that doesn't mean that they suddenly don't have to get AppSec tested before they ship. That just means that there is somebody locally who knows how to recognize an unpaved road that we should not be on, so that by the time it gets to AppSec, there's probably nothing wrong with it, or if there is, it's trivial. And so that Champions program is something that, after I've described it, any number of our customers have come to me and said, okay, where's the URL for that? I need to know sort of the details about how we would do something like that inside of our company. And we've blogged about it. We've got online material that explains how we do it and why we do it and what results we get from it. And that's a pretty, it's not trivial, but it's a low investment. It doesn't require, buying a whole lot of software tooling or hiring a lot of new people. You're just taking the people you have and making them into a distributed web of experts. And that is probably the biggest bang for the buck that an early adopter of Secure by Design is going to get.
Yeah, I love that approach. As we take a look at the next slide, actually, we're kind of moving into how can we continuously evaluate our design and maybe potentially find attack vectors or flaws or things like that we didn't think of. We're humans, as you mentioned. We're not always going to get everything right out of the box. So a lot of times threat modeling is used to take a different lens on this particular product or application and say, instead of looking at only the functional requirements, how can we actually find the ways that we can screw these things up? And I've seen threat modeling used in a lot of different ways over the years, from the safe code, tactical threat modeling guide, a very long kind of process where we do a full threat model and that has to be done before we can ship code to production. I've also seen more of like Mozilla's rapid risk assessment approach, which is, a 15-minute just very quick shot through what's changing from the last time, and documenting that in threat modeling as code and keeping that in the source control repository to just live right next to the system with all the other code that's in there. And as I look at threat modeling, and you mentioned security champions and trying to onboard the people that we have to deal with some of these security, not being the security person, but recognizing when security might need to be more involved, that could also be a nice way to have them involved in a incremental threat modeling discussions, and maybe go report if we're deviating from that paved road, as you mentioned, in some sort of sprint. And as you look at threat modeling and secure by design, what positives have you seen with that, or what are your thoughts on how this fits into a secure by design strategy?
The two problems that underlie the threats are complexity and scale. So, when we are involved in, anyone on this call is involved in defending actively against an attacker who is attacking now, you can predict the outcome to some extent by simply asking the question, does the defender or the attacker understand this technology better? Because whoever understands it best and therefore knows its weaknesses or knows the kinds of weaknesses it might have is most likely going to win. And the sad part is that we in our jobs are rarely in the position where what we are there to do is security, right? We're there to deliver for customers. And so to the extent that we can invest in understanding what we're doing and the security implications of it, that's an added cost. For the bad guys, they got nothing to do except break into other people's stuff. And so they get to spend a lot more time because for them, security is a profit center. For us, it's a cost center. And the asymmetry of incentives gets worse because for an attacker, if they succeed, they know how much they won. But if we succeed, we do not know how much we would have lost. And so that really focuses our attention differently. And so that's where scale comes in. We have to use automation, and we have to understand the risk of complexity and the need for understanding. And of of the bullets on this slide, the one I'd like people to take away is evolution. Your supply chain is in motion. When you're building something, sometimes it fails to build because some other part of the system needed a later version of some module you also need, and your code isn't compatible with those changes, and maybe it looks compatible but has drastic security problems because it's unprepared for what it may then receive. Things like that will always happen. We have to just understand that both the open source supply chain and whatever commercial supply chain we may have are constantly in motion. And we're not going to be doing a background check on every developer to make sure that something like the XZ debacle is not about to occur. So what we have to have is automation to tell us when something we depend on has been revised in some way. And then we have to have enough developer bandwidth to go look at that and say, did they fix a bug? Or what's worse, did they just introduce a bug that they don't realize yet? Is this something we should move to? Is this something we definitely should not move to? And that's evolution. In other words, if you want to ship the same system year on year, which none of us do, but if we did, we would still have to revise it extensively year on year just to make sure that the underpinnings as they evolve are things we have evolved and adapted to. That is a cost that a lot of innovative companies don't budget for. And again, there's a lot of scale that goes into, or excuse me, automation that goes into scaling this so that you're, showing appropriate care for these risks.
Yeah, I think that's a great point as well. And secure by design, it may seem to a lot of people like a static thing. And as you know, if you're in the trenches kind of building these systems, we know that every day one of these components will change, or there'll be a new CVE that comes out with something that is underneath the entire infrastructure that you're using. And understanding that threat models evolve the same way, what we are attacking right now is very different than what we were attacking 5 to 10 years ago with some of these systems. And, as you mentioned, supply chain, I know there's been a ton of kind of, again, the government helping us with supply chain security and, SALSA, the supply chain levels for software artifacts maturity model coming out, and things like that have, I think, really helped us understand the supply chain and what we need to be concerned about from an infrastructure perspective. And, something that I've also noticed is that penetration tests in a way help me evolve my threat model too, is you get that pen test report and it has, let's just say that XC vulnerability came up in a pen test. I immediately know that, well, there's a gap in my threat model, which means I need to turn around in my design and add abuse cases and
Yes.
different attacker stories and things like that. And it's just this constant cycle of just continuous improvement, I think, is where I land with that. Is that what you're seeing with a lot of your, evolution and products as they move forward?
It is, and I don't want to turn this into a commercial for everything we're doing, but I will say that to be secure by design means that you have to be a really good owner of everything that you are contributing. And then you have to be a good steward of everything that you're importing. So we need it to be that, let's say you're building something that has identity and access management as a requirement. It's important to decide early whether that's going to be something that you're known for, whether your company's or your project is going to distinguish itself by being an innovator in that space. If that's part of your plan, then you can, start investing along those lines. If it's not, then you need to make sure that you don't just accidentally hard code something that becomes a big vulnerability later on. And so you'll have to look to a supply chain, either from your system vendor, your cloud vendor, whatever it is that you're building on top of, assuming you're buying computers rather than visiting the beach and getting the sand and making silicon out of it. You need to have a really good understanding of how they manage risk. And then you have to figure out how to make sure that what you do uses the best of what they have. Because it may be that secure by default is not one of the things that your supply chain will offer you in the case of identity and access management. I can remember years after MD5 was broken that there were still so-called secure hashes being generated that were MD5 in nature. And you don't have to know exactly what's wrong with MD5 or how it was fixed or how to build something better. You just have to know that it's broken and that you can't use it and your supply chain can't use it. And so there is just a lot to know. And so in my day job, we spend a lot of time making sure that the defaults are secure and that if you want to do something that will be potentially dangerous for you, that you might get a warning or that it's possible to ask us to evaluate that. We've got various automations around that. And for IAM, interesting example there, we created an open source artifact called Cedar, where you get to link against our library and tell it in a relatively plain language what exactly are the rules. And then it will sort of traverse itself in the right ways to then allow you to do access management at speed, at scale, without understanding all the details, but understanding them well enough that this becomes an area where you are now a responsible steward of your customers' trust.
Yeah, I love that example with Cedar and kind of some of that policy as code that you can slowly start to kind of put into these secure by design ecosystems. The kind of prerequisite to getting to that point, I think, is pretty well illustrated on our next slide, which is just the culture. You can't really talk about secure by design or product security or DevOps or DevSecOps or whatever that means to you without really talking about the culture first. And culture for a long time was something that, was very siloed. And you mentioned kind of having your security champions, and a lot of these initiatives have to do with building a cross-functional team that's got some folks with developer backgrounds and operations and security and now cloud and now compliance, so they can help you write up your policy as code engines to ensure everything is working successfully. What sort of things do you think of when you think of security culture and facilitating this culture where everybody kind of owns these systems rather than the more traditional kind of siloed teams are responsible for their own piece and nothing else approach to just IT in general?
Well, what's evolved for us, and I think this is, that we're not unique in this way, is that the service team owns the responsibility for the security of that service. And the service team includes developers, product managers, leaders, and the way we have organized things in AWS, most of these service teams have their own income and expense, right? We know how much it's costing in people and cloud expense to make that service available, and we know how much we're charging for it. And we can ask the question, is this thing ever going to be profitable, or it was and now it isn't, or whatever. So that we have almost a federation of tiny startups inside of our company. But one of the things that each of those service teams retains is the responsibility for security. So on my team, the AWS security team, we're not there to say no. We're there to say, yes, I understand what you're trying to do. I want you to be able to do it, but there is this thing that will get in the way and will be a problem. And that turns out to be huge, because if you have centralized security and the culture is that there are these mean people down the hallway that are constantly saying no, derailing our train, then what's going to happen is those teams are going to be hostile. They're not going to feel like fellow travelers. They're not going to act like fellow travelers. And so I would say the key to the successful security cultures I've seen is not just that your founder cares about it or your current CEO cares about it, but that everybody cares about it and they are allowed to care about it. So, we have something called the andon cord. It actually comes from lean manufacturing. We didn't invent it, but we've certainly adopted it. If somebody is sure that there is a security problem, they get to yank the cord, and a whole bunch of experts will come and look at it and decide, is this a real problem? Because if it is, then we're not going to continue along the path that was on. And so, security culture starts at the top, ideally with the founder, but it has to be something that the CEO believes, doesn't just speak the slogans, but believes, and that the board supports the CEO for it, and there are metrics across the company for it, and that it's everybody's job. It isn't, some team of those terrible people who always say no. Those are the elements of a successful security culture.
Yeah, I find it interesting too in cultures like that, how the governance model can change a little bit. We always had these separate teams that were dealing with compliance or telling us which risk decisions we were and were not allowed to make. In a culture where security is kind of at the forefront for everybody, whether you're a builder or an owner of the system, I've seen a lot of this start to live with that product team and the product manager and allow them to kind of make their own risk-based decisions on some of these things rather than having to, reach out and get approval, as long as it's documented and that maybe deviation from the design is, if there's a reason for it, right? And I think it does allow you, as you mentioned, to have individual teams kind of operating as their own entrepreneurs inside a much larger organization, and keeps things a little more lean and agile for deploying things a little bit faster.
Indeed. I guess this slide speaks for itself, and we're not going to go through it in detail, but the underlayment here is that security is taken seriously. That, as I mentioned, there is a growing set of very well-trained, highly skilled, high investment, well-incented, well-aligned attackers. It's no longer thinkable that there will be a vulnerability in something that is reachable on the web where exercising that vulnerability will injure somebody and it isn't found, right? There's no obscurity left. We are surrounded. And so it it is necessary that every company, every project, take a look at security and say, we are either going to take this seriously, and that means as follows, we're going to be maybe late to market on the certain features or whatever, or we're not. And we need to be upfront about that. And then they got to stick to that story. I'm mindful of the original network file system, NFS from Sun, where they used numbers. And at first they were 16-bit, but that doesn't matter. They were numbers to indicate the owner of a file. And so on some NFS clients, that number would be associated with a certain username. On other NFS clients who had access to the same file server, that number would be used by a different name. And those names might not be in the same trust perimeter. It might be that they should not both be able to read or write the same set of objects. But, Sun was trying to get to market with a bunch of 68010 hardware, and they did what they could with what they had. And then terrible things happened later when the scale happened. And so we should look at history and we should try and figure out what are we doing because we think we have no choice. And let's do some science fiction now. Let's imagine the worst possible outcome. If somebody who's a real expert at this were to go after it, what could they do? And then, okay, what could we potentially do now to make that harder, make that impossible, make it hard enough that other things would be easier so that what should we do? What can we do? That will always be necessary. We're not, moving towards some shining city on the hill where we don't have to think that way anymore. Quite the opposite.
Yeah, I mean, that kind of brings us back to threat modeling and that iterative process of finding new ways that things can break. As you look at building something with a secure by design mindset and maybe consider a company that has not gone through this process and they're kind of doing things the old way, from a considerations perspective, I always think SDL is kind of at the cornerstone of all of this, defining what does that development lifecycle look like and training people or upskilling them in just the modern kind of CI/CD tooling and doing test-driven development and automating test cases and things like that to get to the point where we can actually start to evaluate this constantly. Aside from that ramp up period, and the fact that they're probably going to get bogged down for a little bit, what else concerns you about going through this and what could go wrong, I guess, as we start to migrate over to a different mindset?
In a venture-driven market, as we sometimes are, a lot of new entrants into that market want to come in and, hit first revenue as quickly as they can. And they are sometimes not willing to sort of think about the risks, right? They care about the features, the performance, things like that, because that they will live or die. They'll either get or not get their next round of venture capital based on whether they have hit first revenue by a certain date. That worries me. And when we try to grow too fast in that way, we end up with some pessimal outcomes. But there is another concern, and that is if you're trying to do the right thing, you generally know what the right thing is, or you've hired consultants or whatever it is. You're really trying to fit yourself to a risk appetite that will make you a responsible steward of your customers' trust. You might think that these are all checklist items that you can just get a bunch of out-of-the-box CI/CD software and plug it in and turn it on, and yeah, it seems to be working. So check that box, we're done. You can't check that box, you're not done. You have to look at the defaults that you got. You have to look at the alternatives. You have to understand enough to know whether you bought the right product or imported the right open source tool that's doing that for you. There's just never going to come a time that some set of builders will be able to just work on the logic, the business logic of what they want their customers to experience and not have at least some peripheral awareness that, hey, I'm in a cloud. I'm using, various cloud-related things for identity, access management, and logging, and all the rest of the stuff, and landing zones, and scale, and so I've got all of these things which are the foundation I'm building on. I, as a developer, might someday want to go build those things myself, but I can't do that here because that's not going to be our unique claim to fame. So we got to focus on things that are our unique claim to fame. You still have to know what you're getting and what the alternatives were and what the alternatives still are in case you need to change it. So to the extent that a company comes into existence and says, yeah, I don't want to have this expertise in my company at all, that may be a mistake. Because while you're not going to have the expertise to build it all, you're going to have the expertise to understand the implications of what it is and how it works and how it's configured. So those are the two risks that I see coming through where the Secure by Design pledge pretty much outlaws both of those behaviors.
Yeah, that's a really interesting lens to that, something that I haven't really given a lot of thought to before. But yeah, understanding what's underneath of it and some of the implications of abstracting that away. We've got just a couple of minutes left here, so I want to make sure we at least touch on the last slide, which is the benefits of kind of going through this process. And I'll just let you jump in here so you can kind of close us out. I mean, what are your thoughts on the biggest benefit or one of the biggest wins that you can see by going through Secure by Design?
Well, when we structured the white paper, of which this presentation is a summary, we really picked things of equal importance. So I know that there can only be one first priority, but everything on this slide turns out to be both important and beneficial. And it all represents responsible investment both upfront and throughout, so that you're not building the wrong kind of technical debt, and so that, when and if one of your customers gets their name in the papers, it's not because of something you failed to do. And, if I could focus anybody on any one thing, it'd be sustainability. The ability to know when things are not going well, or by the silence of such tools, that things are probably okay. That in turn gives you the ability to focus what will always be the scarce resource of management bandwidth and development bandwidth on things that matter more to your customers. But you can only get that through everything else we've talked about.
Excellent. I love that. So with that, Paul, thank you so much for joining us. This is very insightful. I'm looking forward to everybody kind of going through and reading that paper. Frank, I'll pass it over to you for any closing thoughts that you've got, or Paul, any closing thoughts you've got for us?
Hey, that was perfect. Perfect timing, Paul. Eric, thanks for a great session. A lot of great insights, a lot of good comments here on Slack about all of the nuggets of wisdom you dropped, Paul, from your experience. So thank you very much.
Well, thank you for organizing this. It's a privilege to be here.
Glad you could be here. Thank you. With that, let's go ahead and move on now to our next session. And